Chapter 8 Application of Integrals. We have many applications of integrals. Few of them are we can find the displacement, which is the integral of velocity with respect to time t, and we can find the velocity, which is the integral of acceleration with respect to time t. In lower grades, we have found the areas of two-dimensional shapes like triangle, square, rectangle, parallelogram, trapezium, circle, etc. Now, application of integrals can be used to find the areas of two-dimensional figures having curved boundaries. We will see how to find the areas under simple curves. The first one, curves above x-axis. Let y is equal to f of x be the curve. Let us take the limit lines x is equal to a and x is equal to b. Now the area bounded by x is equal to a, x is equal to b, y is equal to f of x curve, and the x-axis is the shaded region. Let us take a thin rectangular strip whose width is dx, height will be y, which is f of x. So area of that rectangle will be length into breadth, and we can divide this area, the shaded region, into so many rectangles. We will sum up all the rectangular areas between x is equal to a and x is equal to b. We will get area of the shaded region. The integral sign, the elongated s, stands for summation of all these rectangular areas. So this is how we calculate the area under the curve bounded by x-axis. Second case, curves below x-axis. Let this be x-axis, origin, this is the negative direction of y-axis, and let us consider a curve y is equal to f of x and take the limit lines x is equal to a and x is equal to b. Let us shade the region bounded by x is equal to a, x is equal to b, the curve y is equal to f of x, and the x-axis. Let us see how to find the area of this shaded region when the curve is below x-axis. If we take a thin rectangular vertical strip whose width is dx, the height will be y. The y coordinate in this case is going to be negative because it is below x-axis. Therefore, the area of the rectangular strip y dx will be a negative quantity. But area cannot be negative. We have to make it a positive quantity, and we have to sum up all the rectangular areas between the limits x is equal to a and x is equal to b. Therefore, integral x is equal to a to x is equal to b of y dx gives you the area of the shaded region, and this area will be negative as the y coordinate is negative. To make the area positive, we will take the absolute value sign of this, or we may write a negative sign to make the area positive. Remember, if the curve is above x-axis, the area will be a positive quantity, and if the curve is below x-axis, the area will be a negative quantity. So to make it positive, write the absolute value sign. The third case is part of the curve is above x-axis and part of the curve is below x-axis. Let us consider a curve which is a straight line and take the limit lines x is equal to a and x is equal to b. Let us shade the region bounded between the line and the x-axis between the given limits x is equal to a and x is equal to b. This region is below x-axis and this region is above x-axis. We have to find the sum of these two, and let this point of intersection be C. We know that this yellow region is below x-axis, so this will get a negative sign, and this region is above x-axis and it will get a positive sign. We have to make that yellow area positive. Therefore, area of the shaded region will be, I will name this as area A and this as area B. So it will be A plus B. So to make that area A positive, I have to write the absolute value sign, and integral, the limits are a to c of y dx, it is bounded by x-axis, plus B area will be integral c to b of y dx, same curve, but it will be positive, no need to write the absolute value sign. The fourth case is with respect to y, that is when the area is bounded by y axis. Let us consider a curve x is equal to f of y. This is y is equal to c line and this is y is equal to d line. Let us shade the region bounded by y is equal to c, y is equal to d and the curve x is equal to f of y and y axis. Here the area is bounded by y axis, so integration has to be done with respect to y. Let us take a thin rectangular horizontal strip whose width is dy, height will be x. Therefore, area of this rectangle will be x times dy, and we have to sum up all the rectangular areas between the limits y is equal to c and y is equal to d. That gives you the area of the shaded region. So remember, if the area is bounded by y axis, the integration has to be done with respect to y. Fifth case is area between two curves. Let us take two curves. This is y is equal to f1 of x and another curve y is equal to f2 of x. And this is x is equal to a and this is x is equal to b. Now we are going to find the area between these two curves and between the limits x is equal to a and x is equal to b. Let us consider a thin vertical strip with width dx. Height of this strip will be f1 of x minus f2 of x. f1 is bigger than f2 in this case. Therefore, area of that rectangular strip is going to be f1 of x minus f2 of x times dx. And we are going to sum up all the rectangular areas between the limits x is equal to a and x is equal to b. This gives the area of the shaded portion. Integral of f1 of x dx will give this region. And then integral of f2 of x dx will give this region under the curve f2 of x bounded by x axis. Now this subtraction gives the yellow area, which is the required area. Therefore, to find the area between two curves, we have to do integral a to b upper curve minus lower curve. Times dx. Before starting the exercise, we will learn all the equations of the curves in their standard form. The first one, lines. Equation of x-axis is y is equal to 0. Second one, equation of y-axis is x is equal to 0. The third one, equation of any line parallel to x-axis will be of the form y is equal to some constant k. Fourth one, equation of any line parallel to y-axis will be of the form x is equal to some constant. And the fifth one, equation of a line in general form is ax plus by plus c is equal to 0. Any linear equation in x and y represents a straight line. And then the next point, if the line equation is ax plus by is equal to 0, that is the constant term is 0, then the line passes through the origin. Next, we will learn the equations of circles in standard forms. The first one, the center of this circle is at the origin, and let the radius be r units. Equation of this circle is x square plus y square equal to r square. Then the second case, center is at the point h comma k, and let the radius be r units. Equation of this circle is x minus h the whole square plus y minus k the whole square is equal to r square. Next, we will learn the equations of parabolas in standard form. We have 4 different equations. Vertex of the parabola is at the origin and axis of the parabola is the positive direction of x-axis. Equation of this parabola is y square is equal to 4ax. Now the second type of parabola is vertex is at the origin, axis of the parabola is negative direction of x-axis. And equation of this parabola is y square is equal to minus 4ax. And the third type is the vertex is at the origin, but the axis of the parabola is the positive direction of y-axis. And equation of this parabola is x square is equal to 4ay. Then fourth type of parabola has the vertex at the origin and direction is negative direction of y-axis. And equation of this parabola is x square is equal to minus 4ay. The next one is ellipse. We have 2 standard forms of ellipse. The first type is the major axis is along x-axis and minor axis is along y-axis. Equation of this ellipse is x square divided by a square plus y square divided by b square is equal to 1. And the center is at the origin. And second type of ellipse is, here the center of the ellipse is the origin and major axis is along y-axis and minor axis is along x-axis. Equation of this ellipse is x square divided by b square plus y square divided by a square is equal to 1. And you have to be thorough with all these equations which are in the standard form. We will be using these 3 integration formulae in this lesson. The first one is integral of a constant is kx, and the second formula is integral of x power n dx, which is x power n plus 1 divided by n plus 1 plus c, and the third formula is integral root of a square minus x square dx, which is x by 2 root of a square minus x square plus a square divided by 2 sine inverse of x by a. If we have a line in the question, we will be using these two, and if it is a parabola question, we need this formula, and if the question has circle or ellipse, we will be using this formula. So be thorough with all these 3 formulae. Now let us do exercise 8.1. First question. Find the area of the region bounded by the curve y square is equal to x and the lines x is equal to 1, x is equal to 4 and the x-axis. Linear in one variable x and quadratic in the other variable always represents a parabola, and we have plus x, so the parabola will be right side parabola. X is equal to 1 and x is equal to 4 are straight lines which are parallel to y-axis. Let us solve the first 2 equations. If x is 1, y square is 1. Therefore, y will be plus or minus 1. The points of intersection are, write the x coordinate first and then the y coordinate. Now we will solve first and the third equations. Let us substitute x as 4, y square will be 4, therefore y is plus or minus 2. The points of intersection are 4, plus or minus 2. Let us sketch the graph. Just roughly we will plot these points. And we know that it is a right side parabola and the vertex is at the origin. Let us join these points to get a parabola. You need not use a graph sheet to draw this. This is y square is equal to x parabola. Write the equation. This is x is equal to 1 line and this is x is equal to 4 line. Now we have to shade the region bounded by the parabola, line x is equal to 1, line x is equal to 4 and the x-axis. It is bounded by x-axis. Let us do the integration with respect to x. The formula is y dx and the limits are 1 to 4. Integral 1 to 4 of, let us find y from the parabola equation. Y square is x. Therefore, y is plus or minus root x. But we are using the curve in the first quadrant. Therefore, we will take plus root x. We will use integral of x power n formula, which is x power n plus 1 by n plus 1. It becomes x power half plus 1. Divided by 3 by 2 can be written as into 2 by 3. And the limits are 1 to 4. Let us substitute the limits. 4 raised to 3 by 2 minus 1 raised to 3 by 2. 2 by 3 times 4 power half is 2, 2 cube is 8 and minus 1. 7 2s are 14 divided by 3 square units. Second question, find the area of the region bounded by y square is equal to 9x, x is equal to 2, x is equal to 4 and the x-axis in the first quadrant. This is linear in one variable, quadratic in the other variable. It represents a parabola and plus x, therefore positive x-axis is the axis of the parabola. X is equal to 2 and x is equal to 4 are straight lines which are parallel to y-axis. Let us first find the points of intersection. That is our first step. Let us solve the first and the second equations. If x is 2, y square is 18. Therefore, y is equal to plus or minus root 18, which is plus or minus 3 root 2. Therefore, the points of intersection are 2, plus or minus 3 root 2. Now, we will solve the first and the third equations. Substitute x as 4, y square is 4 9s are 36. Therefore, y is plus or minus root 36, which is 6. Therefore, the points of intersection are 4, plus or minus 6. Let us sketch the graph. 3 root 2 value is approximately 3 times 1.414. We will take 4 1. Approximately 4.2, 2, 4.2 and similarly 2, minus 4.2 and then 4 6, 4, minus 6. We know that this parabola is right side parabola and the vertex is at the origin. Let us join these 5 points. This is the parabola. This is x is equal to 2 and this is x is equal to 4 line. Now we have to shade the region in the first quadrant. If you take a thin vertical strip whose width is dx, height will be y. So area of that rectangle will be y dx. The area is bounded by x-axis, so we will do integration with respect to x and sum of all the rectangular areas between 2 and 4. This is the area of the shaded region. And y from the parabola equation is root of 9x dx and root 9 is 3, which is a constant. We can take it outside the integral. X power half plus 1 is 3 by 2 divided by 3 by 2, which can be written as 2 by 3 and the limits are 2 to 4. 2 times 4 raised to 3 by 2 minus 2 raised to 3 by 2. 2 times 4 power half is 2, 2 cube is 8, and this is root 2. Root 2 cube is 2 root 2. We can take 2 common. 4 times 4 minus root 2 square units. Question 3. Find the area of the region bounded by x square is equal to 4y, y is equal to 2, y is equal to 4, and the y-axis in the first quadrant. The first step is solving the equations and finding the points of intersection. Let us substitute y is equal to 2. Therefore, x square is 4 2s are 8. X will be plus or minus square root of 8, which is plus or minus 2 root 2. Therefore, the points of intersection are, be careful while writing the points of intersection. Write the x coordinate first, then the y coordinate. Now we will solve first and the third. Y is 4. Therefore, x square is 4 4s are 16. Therefore, x will be plus or minus 4. The points of intersection are, write the x coordinate first and then the y coordinate. We will sketch the graph. X square is equal to 4y is a parabola because linear in one variable, quadratic in the other variable, and linear variable is plus 4y. Therefore, it is an upward parabola. The approximate value of 2 root 2 is 2 times 1.41, which is 2.82. Approximately it is 2.8. 2 root 2 comma 2. So approximately 2.8 comma 2 and minus 2.8 comma 2. And then 4 comma 4 and minus 4 comma 4. It is an upward parabola. Vertex is at the origin. Let us complete the parabola. And y is equal to 2 is a line parallel to x-axis which passes through y is equal to 2 value. And y is equal to 4 is also a line parallel to x-axis. Now the area is bounded by these 4 curves: parabola, y is equal to 2, y is equal to 4, and the y-axis. Let us shade the region in the first quadrant. Now this region is bounded by y-axis, so we will do integration with respect to y. Therefore, area will be integral x dy, and the limits for y variable are 2 to 4. We will substitute for x from the parabola equation. Parabola equation is x square is equal to 4y. Write the parabola equation in the figure. Therefore, x will be 2 root y dy. So, 2 times y power half plus 1, which is 3 by 2 into 2 by 3, and the limits are 2 to 4. 4 divided by 3 times upper limit minus the lower limit. Let us simplify. 4 power half is 2, 2 cube is 8, minus root 2 cube is 2 root 2. 2 is common. It becomes 8 by 3 times 4 minus root 2 square units. Question number 4. Find the area of the region bounded by the ellipse x square divided by 16 plus y square divided by 9 is equal to 1. A square is the bigger number, which is 16. Therefore, a is 4. B square is 9. B is 3. This is first type of ellipse. Major axis is along x-axis. A is 4. B is 3. We have to find the area of the ellipse. An ellipse is symmetrical about x and y axes. We will find this one area and we will multiply it by 4. because all these four areas are equal. I will name it as area A. Therefore, area of the ellipse is 4 times area A, 4 times integral. We can do integration with respect to x or with respect to y. In this case, we will do with respect to x. The x limits are 0 to 4, y dx. We have to find y from the ellipse equation. Ellipse equation is x square divided by 16 plus y square divided by 9 is equal to 1. Therefore, y square by 9 is 1 minus x square by 16. Take LCM to avoid coefficient for x term. Therefore, y square is 9 divided by 16 times 16 minus x square. Y will be, we are not going to write plus or minus sign because we are going to use the curve in the first quadrant. Therefore, plus 3 by 4 times root of 4 square minus x square. Area is 4 times integral 0 to 4, y is 3 by 4 times root of 4 square minus x square dx. Remember, if you have ellipse or circle in the question, we have to use this formula. Integral root of a square minus x square dx is equal to x by 2 root of a square minus x square plus a square by 2 sine inverse of x by a. 4 could be cancelled. By applying this formula, we get x by 2 root of 16 minus x square plus a square by 2. A square is 16. 16 by 2 sine inverse of x by 4. And the limits are 0 to 4. We can apply the limit separately for each term. This is equal to 3 times. Upper limit will be 0 because 16 minus 16. Lower limit is 0 because of this x. 0 minus 0 plus 8 times sine inverse of 4 by 4 is 1. Sine inverse of 1 is pi by 2 minus sine inverse of 0 by 4 is 0. 24 times sine inverse of 1 is pi by 2 and sine inverse of 0 is 0. Therefore, the answer is 12 pi square units. Question number 5. Find the area of the region bounded by the ellipse x square divided by 4 plus y square divided by 9 is equal to 1. The bigger number is with y. Therefore, it is the second type of ellipse. Here a is 3, b is 2. Always we take the bigger number as a in an ellipse. We will find this area and multiply it by 4 as ellipse is symmetrical about x and y axis. This is 3 and this is 2. The area is bounded by x axis as well as y axis, so we may do with respect to x or with respect to y. Let us do with respect to x. With respect to x, the limits are 0 to 2. Therefore, area will be 4 times a. I am doing the integration with respect to x axis. Therefore, y dx is the formula. And we have to write x is equal to 0 and x is equal to 2 limits. If you do with respect to y, the limits will be 0 to 3. Let us find y from the equation of the ellipse. Y square divided by 9 is 1 minus x square divided by 4. Take LCM to avoid the coefficient. 4 minus x square. Therefore, y square will be 9 divided by 4 times 4 minus x square. Y will be, no need to take plus or minus sign because we are using the curve in the first quadrant, so positive sign. 4 times integral 0 to 2 of 3 by 2 is a constant, let us write it outside, and root of 2 square minus x square dx. And we will be using this formula. Integral root of a square minus x square dx is equal to x by 2 root of a square minus x square plus a square divided by 2 sine inverse of x divided by a. This is the formula which we need when we have circle or ellipse in the question. 2 3s are 6. X divided by 2 root of 4 minus x square plus a square divided by 2 sine inverse of x divided by 2, and the limits are 0 to 2 and 0 to 2. Let us apply the limits. 6 times the upper limit will become 0 and the lower limit is also 0 because of x. 2 times sine inverse of 1 minus sine inverse of 0. The answer is 12 times pi by 2. Sine inverse of 0 is 0. The answer is 6 pi square units. Question number 6. Find the area of the region in the first quadrant enclosed by x-axis, the line x is equal to root 3y, and the circle x square plus y square is equal to 4. And the area is in the first quadrant. We will solve these two equations. Let us substitute for x square. Root 3y the whole square plus y square is 4. 3y square plus y square is 4. 4y square is 4. Y square is 1. Therefore, y is plus or minus 1. If y is plus 1, x will be root 3 times y. And if y is minus 1, x will be minus root 3. Therefore, the points of intersection are, be careful, you have to write the x coordinate first. Now, let us sketch the graph. X square plus y square equal to 4 is a circle with center at the origin and radius 2 units, and x is equal to root 3y is a straight line passing through the origin. The circle is x square plus y square is equal to 2 square. The radius is 2 units. And y coordinate is easy to plot. Y coordinate is 1 and minus 1. The point of intersection will be on the circle. This is root 3 comma 1 and this is minus root 3 comma minus 1. Joining these 2 points, we get x is equal to root 3y line. It passes through the origin as there is no constant term in the linear equation. We will shade the region in the first quadrant enclosed by x-axis, the line and the circle. So, this is the area to be calculated. But see the upper curve, we have 2 different curves. So, we will split this area into 2. This is root 3. I will name this area as A and this as B. We have to find A plus B. So, the shaded region is area A plus area B. Now, area A is under the line and look at the limits 0 to root 3. Integral 0 to root 3 of y dx. I am doing with respect to x because it is bounded by x-axis. I have to take y from the line equation. I will write yl dx plus B area is under the circle and the limits are root 3 to 2. Look at the figure and write the limits. And y dx, which y I have to use? From the circle equation. So, I will write it as yc dx. Let us substitute integral 0 to root 3 of y from the line equation is x divided by root 3 plus integral root 3 to 2 of y from the circle equation, which is root of 2 square minus x square dx. Again the same formula. If you have a circle or ellipse, we will be using that root of a square minus x square formula. 1 by root 3 times x square divided by 2, and the limits are 0 to root 3, and let us use that formula. X by 2 root of a square minus x square plus a square by 2 sine inverse of x by a, and don't forget the limits. This is equal to 1 by 2 times root 3. Root 3 square is 3 and the lower limit is 0, plus upper limit is 0 minus lower limit is root 3 divided by 2. Root of 4 minus 3 is 1. 4 by 2 is 2. Sine inverse of 1 is pi by 2 minus sine inverse of root 3 by 2 is pi by 3. This becomes root 3. Root 3 divided by 2 minus root 3 divided by 2 and plus 2 times pi by 6. Therefore, the answer is pi by 3 square units. Question 7. Find the area of the smaller part of the circle. X square plus y square is equal to a square, cut off by the line x is equal to a divided by root 2. This is a circle whose center is at the origin and radius is a units, and this is a line which is parallel to y axis. Let us solve these two equations. Substitute for x, which is a square divided by 2 plus y square is a square. Therefore, y square will be a square minus a square divided by 2. Y will be plus or minus a divided by root 2. And a divided by root 2, approximately it is 1.414a divided by 2, which is 0.7a approximately. Just a rough sketch will do. Therefore, the points of intersection are a divided by root 2, comma, plus or minus a divided by root 2. Let us sketch the graph. This is the circle whose center is at the origin and the radius is a units. And x is equal to a by root 2, approximately 0.7a. This is the line x is equal to a divided by root 2, which is parallel to y axis, and this value is a divided by root 2. Now we will shade the region. Smaller part of the circle cut off by this line. We have to find this area. I will name this as a. It is symmetric about x axis, therefore we will do 2 times a. Therefore, area will be 2 times area A. It is bounded by x axis. We will do with respect to x. Therefore, y dx is the formula, integral of y dx. The limits are a divided by root 2 to a. Let us substitute for y from the circle equation. Y square is a square minus x square. Therefore, y will be root of a square minus x square dx. We will use the formula x by 2 root of a square minus x square plus a square divided by 2 sine inverse of x by a. Please memorize this formula. And the limits are a by root 2 to a by root 2 to a. 2 can be cancelled. Upper limit will be 0. Lower limit is a divided by root 2 times root of a square minus a square by 2 plus a square times sine inverse of 1, which is pi by 2, minus sine inverse of 1 by root 2. It becomes minus a divided by root 2 times, this is a square by 2, which will become a by root 2, plus a square times pi by 2 minus pi by 4. Therefore, the answer is pi by 4 a square. I have written the second term first, minus a square by 2. A square by 2 is common. We get pi by 2 minus 1 square units. Question 8. The area between x is equal to y square and x is equal to 4 is divided into two equal parts by the line x is equal to a. Find the value of a. Let us solve these two equations. Y square is 4. By substituting x as 4, y will be plus or minus 2. Therefore, the points of intersection are, write the x coordinate first and then the y coordinate. Let us sketch the graph. The first one is a parabola. Positive x-axis is the axis of the parabola. On the x-axis 4 and on the y-axis 2 and minus 2. The points are 4, 2 and 4, minus 2, and the parabola's vertex is at the origin. Let us join these points and complete the parabola. Write the equation of the parabola. X is equal to y square, and this is 4, 2, 4, minus 2. X is equal to 4 is a line parallel to y-axis. X is equal to 4. Now, the area between the parabola and the line is divided into two equal parts by a line x is equal to a. We don't know the value of a, so we will take somewhere here. Let this be x is equal to a line. We have to find the value of a so that these two areas are equal. This area is equal to this area. Actually, this yellow area is equal to this blue area, but if the full areas are equal, half of them are also equal. We will equate A and B areas. So, area A is equal to area B, and both these areas are bounded by x-axis. So, I am going to do integration with respect to x-axis. Area A is integral 0 to a of y dx, and this is integral a to 4 of y dx. Same curve, same y we have to substitute. Y square is x, therefore y will be square root of x. A to 4 square root of x dx, and x power n plus 1 by n plus 1 formula, x raised to 3 by 2 divided by 3 by 2 can be written as 2 by 3 in the numerator, and the limits are 0 to a. Same integral here also, and the limits are a to 4. We can cancel these two. Let us substitute the upper limit and then the lower limit. Here 4 raised to 3 by 2 minus a raised to 3 by 2. So, 2 times a raised to 3 by 2 is 4 raised to 3 by 2, which is 4 power half is 2, 2 cube is 8. Therefore, a power 3 by 2 is 8 by 2, which is 4. We have to find the value of a. Raising it to power 2 by 3 on both sides, we get 4 power 2 by 3. And this is the answer for a. Question number 9. Find the area of the region bounded by the parabola y is equal to x square and y is equal to absolute value of x. Y is equal to x square is a parabola whose axis is the positive y axis, and absolute value of x is V-shaped curve. It will be of this form. Let us solve these two equations. If we remove the absolute value sign, we have to put plus or minus sign. So we have two lines,
y is equal to x and y is equal to minus x.
Let us solve y is equal to x and the parabola y is equal to x square. So we get x square is equal to x square minus x will be 0. Take x out. We get two answers for x. X is equal to 0 and x is equal to 1. If x is 0, y is also 0. Here y is 1. We have got 2 points of intersection 0, 0 and 1, 1. Similarly, we will solve y is equal to minus x and y is equal to x square. So, x square is equal to minus x and we get x square plus x is equal to 0. X is common. We get two answers for x. X is equal to 0 is one solution and x is equal to minus 1. Let us calculate the corresponding values of y. Y is minus x here. So, y becomes plus 1. We get 2 points of intersection from this case 0, 0 and minus 1, 1. Let us sketch the graph. 1, 1 is this point, 0, 0 is the origin and minus 1, 1. It is an upward parabola, we know. Vertex is at the origin. Let us complete the parabola. And now we have to draw y is equal to x line. This is y is equal to x line and this is y is equal to minus x.
We should not extend these lines below x-axis because in the equation y is equal to absolute value of x, y cannot be negative.
Now we have to find the area bounded by these two curves. So this region as well as this, and it is symmetric about y-axis. We will find area A and multiply it by 2. Therefore, the required area is 2 times area A. Now let us draw the limit line. Now area A is bounded between two curves. Whenever area is between two curves, we have to do upper curve minus lower curve. So I will write 2 times integral 0 to 1. I am going to do with respect to x-axis. So upper curve is a line here minus lower curve is a parabola. So YL minus YP. L stands for line and P stands for parabola, and dx, which is equal to 2 times integral 0 to 1 of y from the line equation. We are using the first quadrant line, which is y is equal to x. So x minus, and parabola equation is y is equal to x square times dx. The integration is so simple. Integral of x is x square divided by 2 and the limits are 0 to 1, and integral of x square is x cube divided by 3 and the limits are 0 to 1. Or you may substitute the limits together for both the terms. 2 times half into upper limit minus lower limit minus 1 by 3 times upper limit minus lower limit. 2 times half minus 1 by 3, which is 2 times LCM is 6, 3 minus 2 is 1. Therefore, the answer is 1 by 3 square units. Question number 10. Find the area bounded by the curve x square is equal to 4y, which is a parabola, and the line x is equal to 4y minus 2.
This parabola is an upward parabola.
Let us solve these two equations. X is equal to 4y. 4y is x square from this parabola equation. X square minus 2. Therefore, we get a quadratic equation x square minus x minus 2 is equal to 0, which can be factorized as x minus 2 times x plus 1. We get two answers for x. X is equal to 2, x is equal to minus 1. Let us find the corresponding y values. Y is x square divided by 4. Therefore, y will be 4 divided by 4, which is 1, and here y will be minus 1 the whole square divided by 4. Therefore, the points of intersection are 2, 1 and minus 1, 1 by 4. Let us draw the figure. 2, 1 point is here and minus 1, 1 by 4. The parabola passes through the origin. Let us complete the parabola and write the equation of the parabola. X square is equal to 4y. The line also passes through these 2 points. This is x is equal to 4y minus 2 line, and the points of intersection are 2, 1 and this is minus 1, 1 by 4, and we have to find the area bounded between these 2 curves. We will draw the limit lines. Here the area to be calculated is between 2 curves. Whenever area is between 2 curves, we have to do upper curve minus lower curve. Therefore, the required area is, I am doing with respect to x axis, and for both the curves the limits are minus 1 to 2. See the line as well as the parabola. Minus 1 to 2 of y of upper curve here is line, minus y of lower curve is parabola, times dx. Integral minus 1 to 2, let us substitute for y from the line equation. The line equation is x is equal to 4y minus 2. I will write it here. See the first line. 4y is x plus 2. Therefore, y will be x plus 2 divided by 4. It is 1 by 4 times x plus 2 dx, minus the second integral is minus 1 to 2 of y from the parabola equation, which is x square divided by 4 dx. This is equal to 1 by 4 times integral of x is x square divided by 2 plus integral of 2 is 2x minus 1 by 4 has been taken out, x cube divided by 3, and the limits are minus 1 to 2. You may substitute the limits separately for each term or together for all the 3 terms. 1 by 4 times half into upper limit minus lower limit plus 2 times upper limit minus lower limit minus 1 by 3 times 2 cube is 8 minus of minus 1 cube is minus 1. This is equal to 1 by 4 times 3 divided by 2 plus this is 2 plus 1, 3. 3 2s are 6 and this is 9. 9 by 3 is 3, which is 1 by 4 times 3 by 2 plus 3. 1 by 4, 2 is the LCM, 9 by 2. Therefore, the answer is 9 by 8 square units. Question number 11. Find the area of the region bounded by the curve y square is equal to 4x, which is a parabola, right side parabola, and the line x is equal to 3. And this line x is equal to 3 is parallel to y axis. Let us solve these equations. If x is 3, y square is 12. Therefore, y will be plus or minus root 12, which is plus or minus 2 root 3. Therefore, the points of intersection are 3, plus or minus 2 root 3. 2 root 3 is 2 times 1.73 approximately. 3.46, 3.5 approximately we will take. Just a rough sketch will do. 3, 2 root 3 is here and 3, minus 2 root 3. And it passes through the origin and the parabola is a right side parabola. Let us complete the parabola. y square is equal to 4x. Write the equation in the figure. And now we will draw x is equal to 3 line. And we have to find the area bounded by these two curves. And the area is symmetric about x-axis. So we will find area A and multiply it by 2. Therefore, the required area is 2 times area A, which is 2 times integral. I am doing with respect to x. Therefore, the limits for x are 0 to 3. Y dx is the formula. Let us substitute y from the parabola equation. X is equal to 3 becomes a limit here. Y from the parabola is root of 4x dx, which is 2 2s are 4. 4 times integral 0 to 3 of root x dx. Use x power n plus 1 by n plus 1 integration formula. X raised to half plus 1 is 3 divided by 2 times 2 by 3, and the limits are 0 to 3. 8 by 3 times upper limit minus the lower limit. 8 by 3 times root 3 cube. Root 3 cube is 3 root 3. Therefore, the answer is 8 root 3 square units. Question 12. Area lying in the first quadrant and bounded by the circle x square plus y square is equal to 4 and the lines x is equal to 0 and x is equal to 2. This is a circle whose center is at the origin and radius is 2 units. X is equal to 0 is the equation of y-axis. An equation of this circle is x square plus y square is equal to 2 square. The radius is 2 units. X is equal to 2 is a line parallel to y-axis. This is x is equal to 2 line. We have to find the area in the first quadrant bounded by the circle and these lines. Let us shade the region. This is the area to be calculated. Here we can do with respect to x-axis or with respect to y-axis. Let us do with respect to x. Therefore, area is integral y dx and the limits for x variable are 0 to 2. Therefore, integral 0 to 2 of y from the circle equation is root of 2 square minus x square dx. We have to use integral root of a square minus x square dx formula. X by 2 root of a square minus x square plus a square by 2 sine inverse of x divided by a. Therefore, the integral is x divided by 2 root of 4 minus x square plus here a square. A square is 4, 4 divided by 2 sine inverse of x by 2 and the limits are 0 to 2. Here also the limits are 0 to 2. Upper limit will become 0. The lower limit is also 0 because of this x. Plus 2 times sine inverse of 1 minus sine inverse of 0. And sine inverse of 1 is pi by 2, sine inverse of 0 is 0. Therefore, the answer is pi square units. And the correct option is A.
Area of the circle is pi r square and this is quarter circle. Therefore, it is 1/4 of pi r square.
Question number 13. Area of the region bounded by the curve y square is equal to 4x. It is a parabola because it is linear in one variable and quadratic in the other variable. And it is right side parabola. Y axis and the line y is equal to 3. If y is 3, 9 is equal to 4x. So x will be 9 divided by 4. Therefore, the point of intersection is 9 divided by 4, 3. And 9 divided by 4 is 2.25. 9 by 4, 3 will be here. And the parabola is a right side parabola, we know. It passes through the origin. Let us complete the parabola. And symmetrically we can draw on the other side. Write the equation of the parabola, which is y square is equal to 4x. Y is equal to 3 line is parallel to x axis. And we have to shade the region bounded by the parabola, y axis and the line. This is the area to be calculated. Since the area is bounded by y axis, we will do integration with respect to y. Therefore, area is equal to integral x dy. We are doing integration with respect to y, therefore we have to write the y limits. The limits are 0 to 3. The area is bounded between the parabola and y axis, so we will use parabola equation. X from the parabola equation is y square divided by 4. And integral of y square is y cube divided by 3. And the limits are 0 to 3. 1 by 12 times 3 cube is 27 minus 0. Therefore, the answer is 27 over 12. We can cancel 3. The answer is 9 by 4 square units. And the correct option is B. Example 5. Find the area bounded by the ellipse x square divided by a square plus y square divided by b square is equal to 1, and the ordinates x is equal to 0, x is equal to ae, where b square is equal to a square times 1 minus e square. This ae is c, which we learnt in 11th standard. X is equal to 0 is the equation of y axis, and we have to draw x is equal to ae line which passes through the focus. Let this be ae, which is c. This is x is equal to ae, where e is the eccentricity of the curve. For an ellipse, eccentricity is less than 1, we know. For hyperbola, eccentricity is greater than 1. Let us shade the region. We have to find this area. We will find area A and multiply it by 2. Therefore, the required area is equal to 2 times area A, which is 2 times, it is bounded by x axis, we will do integration with respect to x. So, y dx is the formula, and we have to write the limits for x, which is 0 to ae. We will find y from the ellipse equation. X square divided by a square plus y square divided by b square is 1. Therefore, y square by b square is 1 minus x square divided by a square. Take LCM to avoid coefficient for x term. Therefore, y square is b square divided by a square times a square minus x square. Y will be, no plus or minus sign required here because I am using the curve which is in the first quadrant. So, plus sign. Let us substitute for y. 2 times integral 0 to ae. Y is b by a times root of a square minus x square dx. The formula is x by 2 root of a square minus x square plus a square divided by 2 sine inverse of x divided by a. I am repeating, we will get this formula only when we have circle or ellipse in the question. 2b divided by a times upper limit will be ae divided by 2 root of a square minus a square e square, and lower limit is 0, plus a square divided by 2 sine inverse of ae by a is e minus sine inverse of 0 by a is 0. Two b by a ae by 2 root of a square is common. We get a square times 1 minus e square plus a square by 2 sine inverse of e. Sine inverse of 0 is 0. This is given as b in the question. See here, see the first line, b square is a square times 1 minus e square. Therefore, we get 2b by a times ae by 2. This becomes b. We may give the answer in terms of b or in terms of e also, you may write. A square divided by 2 sine inverse of e. A by 2 is common. We will take a by 2 out. We get eb plus a sine inverse of e. Therefore, the answer is b times eb plus a sine inverse of e.